When officials announce a new El Niño pattern, we typically brace for a specific set of disasters. We look for the visible signs of devastation: parched crops, empty reservoirs, and raging wildfires. But disaster mitigation specialists track these climate drivers for a reason that rarely makes the evening weather report. These cycles act as threat multipliers, triggering complex ecological chain reactions that alter the way wild animals and humans interact. When El Niño synchronizes with the positive Indian Ocean Dipole, resulting droughts compress wild habitats and can ignite deadly zoonotic disease outbreaks, like Nipah virus. This temperature map shows the first domino. The purple and white band across the tropical Pacific marks an intense El Niño, warming the ocean's surface and disrupting global wind patterns. Simultaneously, a positive Indian Ocean Dipole warms the western Indian Ocean, while cooling the waters near Indonesia and Malaysia. When these two phenomena synchronize, they create a climate double whammy that aggressively shuts down the monsoon rains across South and Southeast Asia. This creates a landscape defined by record-breaking heat waves and extreme, prolonged droughts that turn waterways into debris-strewn dust bowls. Deep in the rainforest, the lack of rain suffocates the ecosystem, causing wild trees to fail to produce fruit and flowers. This climate-driven botanical failure effectively removes the primary food source for native wildlife, leaving species in a state of ecological starvation. The flying fox fruit bat is a native resident of these forests and the natural reservoir for the Nipah virus. Under the pressure of starvation, millions of these bats are forced to undergo desperate emergency migrations. They abandon the rainforest for human-dominated agricultural zones, seeking calories in cultivated mango and durian orchards. During the 1997-1998 El Niño event in Malaysia, these commercial fruit orchards were often integrated with intensive pig farming operations. Bats feeding in the orchard canopy dropped saliva-stained fruit and urine directly into the open pig pens below. The pigs ate the contaminated fruit, serving as an amplifier host that rapidly spread the virus through the livestock population. The amplified virus then spilled over into the farmers. The resulting outbreak killed over 100 people and forced the culling of 1 million pigs, decimating the local economy. We cannot stop massive ocean atmosphere cycles, but we can recognize that pandemic preparedness is increasingly linked to environmental awareness. Mitigation depends on structural biosecurity, the practice of building physical firewalls between wild ecosystems and human agriculture. If you raise livestock in bat regions, ensure their pens are fully roofed and structurally isolated from any overhanging fruit trees. Human food sources require similar defense. For instance, date palm sap collection pots should be protected with bamboo skirts or netting to prevent bat access. Noticing shifts in wildlife behavior, like bats roosting closer to homes, is a signal to immediately heighten sanitation and protective protocols. Stockpiling canned goods and water is a baseline for many, but survival in a changing climate requires a broader perspective. It requires mapping the hidden ecological dominoes that nature knocks over during a weather crisis. By tracking macroclimate anomalies like El Niño, we gain a clear lead time on biological threats, the window of opportunity to prepare before an outbreak arrives.